Hi students, welcome to the extended chapter on triangles. In the slide you see, in two equiangular triangles, the ratio of corresponding sides are equal to the ratio of corresponding altitudes by theorem. So we have to prove BC by EF is equal to AL by DM by theorem. AL and DM are altitudes in triangle ABC and DEF respectively. AL perpendicular to BC and DM perpendicular to EF. In triangle ABC and DEF, AB by DE is equal to BC by EF. ABC is similar to DEF. Equation 1. In triangle ALB and DME, angle ALB is equal to angle DME is equal to 90 degree. Angle B is equal to angle E corresponding angles. So by AA similarity, ALB triangle is similar to DME. Therefore, AB by DE is equal to AL by DM, equation 2. From equation 1 and equation 2, it is proved that BC by EF is equal to AL by DM. In the next theorem, if two triangles are equiangular, prove that the ratio of the corresponding sides is equal to the ratio of corresponding medians of triangle ABC and DEF. So ABC and DEF are two triangles. AL is median in ABC, DM is median in DEF. So AL bisects BC and DM bisects EF. To prove BC by EF is equal to AL by DM by this theorem, since triangles are equiangular, their sides must be proportional. Therefore, AB by DE is equal to BC by EF. Medians AL from vertex A and DM from vertex D meet midpoints of BC at L and EF at M respectively. Therefore, 2BL is equal to BC and 2EM is equal to EF. Substituting values for BC and EF, we get AB by DE is equal to BC by EF is equal to 2BL by 2EM, which simplify to BL by EM. Therefore, AB by DE is equal to BL by EM. Angle B is equal to angle E. Corresponding angles are equal. Therefore, by SAS similarity, ABL is similar to DEM. So, AB by DE is equal to BL by EM is equal to AL by DM. Hence, the theorem is proved. In equiangular triangles by theorem, the ratio of corresponding sides is equal to the ratio of corresponding angle bisector segments. In ABC, AX is an angle bisector. So, BAX is equal to half A is equal to CAX. ABC similar to DEF. In DEF, dy is angle bisector. EDY is equal to half angle D is equal to FDY. AB by DE is equal to BC by EF by equation 1. In triangle ABX and DEY, angle BAX is equal to angle EDY, angle A is equal to angle D, half angle A is equal to half angle D, angle B is equal to angle E by AA similarity, AB by DE is equal to BC by EF is equal to AX by DY. Hence proved. In the next theorem, if a perpendicular is drawn from the vertex of a right angle triangle to its hypotenuse, then the triangles on either side of the perpendicular are similar to each other and to the whole triangle. In the picture you see ABC is a right angle triangle. Right angled at C, a perpendicular is drawn from its vertex C perpendicular to the hypotenuse AB. We have to prove that CD squared is equal to BD into AD. In triangle ABC, according to Pythagoras theorem, AB squared is equal to AC squared plus BC squared. Also we know AB minus BD is equal to AD and AB minus AD is equal to BD on the hypotenuse side AB. In triangle ADC, AC squared is equal to CD squared plus AD squared by equation 1. In triangle BDC, BC squared is equal to BD squared plus CD squared equation 2. AB squared is equal to AC squared plus BC squared. Adding equation 1 and equation 2 simultaneously, we get AB squared within bracket CD squared plus AD squared plus BD squared plus CD squared within bracket. Therefore, AB squared is equal to 2CD squared plus AD squared plus BD squared. So, AB squared minus AD squared is equal to 2CD squared plus BD squared. Applying the identity a squared minus b squared, a plus b into a minus b, to ab squared minus ad squared, we get ab plus ad multiplied by ab minus ad is equal to 2cd squared plus bd squared. Then ab minus ad becomes bd. Therefore, ab plus ad multiplied by bd is equal to 2cd squared plus bd squared. That gets extended to AB plus AD into BD minus BD squared is equal to 2CD squared. Taking common BD out, we get BD multiplied by AB plus AD minus BD is equal to 2CD squared. Then BD within bracket AB minus BD plus AD is equal to 2CD squared. AB minus BD becomes AD. Therefore, BD into AD plus AD is equal to 2CD squared. BD into 2AD squared is equal to 2CD squared. 2 into AD into BD is equal to 2CD squared. Therefore, CD squared is equal to AD multiplied by BD. Following the theorem, we have a right angle triangle ABC right angled at A. AD is drawn perpendicular to BC. Find the length of AD, AC and AB. If a perpendicular is drawn from the vertex of a right angle triangle to its hypotenuse, then by the theorem, the triangles on both sides of the perpendicular are similar to each other and to the whole triangle itself. AD is drawn perpendicular to the hypotenuse BC. It splits it into two segments such that AD squared is equal to CD into BD by theorem. Therefore, AD squared is equal to 5 into 8, which is equal to root 40, which is equal to 2 root 10 is the side length of AD. Apply Pythagoras theorem to find AC. AC squared is equal to AD squared plus CD squared, which is equal to 2 root 10 squared plus 5 squared. Therefore, AC is equal to root 65. AB squared similarly is equal to AD squared plus BD squared, that is 40 plus 64 root 104. BC squared is equal to AC squared plus AB squared. That takes us to root 169, which is 13 centimeter. In triangles ABC and DEF, ABC is similar to DEF. If they are similar, then their sides are proportional. Therefore, BC by DE is equal to EF by CA. Then which of the corresponding angles are equal? Now think about the ratios. Here the ratios of two corresponding sides are given and the angle included between them should be equal. Therefore, BC and DE are said to be proportional to sides CA and EF. The angle included between BC and AC in triangle ABC is angle C. The angle included between sides DE and EF is angle E in triangle DEF. Therefore, corresponding angles C is equal to E and therefore the triangles are similar by SAS similarity. In the next slide, you see ABC is a triangle. We have to prove which line segment is parallel among DE and BC, EF and AB, DF and AC. Let us take DE and BC. If DE is parallel to BC, then between triangle ADE and ABC, AD by DB is equal to AE by AC should be proportional. Therefore, 2.5 by 7.5 is equal to 3 by 7. Therefore, 1 by 3 not proportional to 3 by 7, DE not parallel to BC. Then taking DF and AC between triangles BFD and BCA, BD by AB is equal to BF by BC, 5 by 7.5 is equal to 10 by 15, which is equal to 2 by 3. Therefore, DF is parallel to AC. Between EF and AB, then between triangles CEF and CAB, CF by BC is equal to EC by AC, 5 by 15, not equal to 4 by 7, EF not parallel to AB. In two triangles ABC and RPQ, AB by QR is equal to BC by PR is equal to CA by QP. Sides are proportional. Then ABC similar to QRP by SSS similarity criteria. We can also say PQR similar to triangle CAB and BCA similar to RPQ. Here, hypermarket was between houses A and B. The height of house A is 30 meters and it casts a shadow of 15 meters. The tower of hypermarket casts a shadow of 45 meters on the ground. Find the height of the hypermarket and the height of house B. In triangle ABC, DEF, LMN are similar triangles by SAS criteria. Angle LMN is equal to angle ABC is equal to angle DEF is equal to 90 degree. The sides including these angles must be proportional. Therefore, LM by MN, which is equal to 30 by 15, which is equal to AB by BC, which is equal to AB by 45, which is equal to DE by 10. Therefore, AB by BC is equal to DE by EF is equal to 2. AB by 45 is equal to 2. So, AP hypermarket tower is 90 meters. Then height of house B, DE by 10 is equal to 2. Then height of house B is equal to DE is equal to 20 meters. A boy went to a lighthouse by bicycle, and in the stone wall writings there he found the height of lighthouse was stated as 18.9 meters. The boy is 90 centimeter tall, cycled back home in 16 seconds at a speed of 2.5 meter per second. He parked his bicycle and found his shadow stretching away from the lighthouse direction. Find the length of his shadow and also the ratio of AC is to CE. Boy height CD is equal to 90 centimeter. Lighthouse AB height is equal to 18.9 meters. BD is the distance cycled by the boy back home. 16 into 2.5 meter per second gives us 40 meters. So the boy cycled 40 meters back home. Let the boy's shadow stretched be DE, which is equal to X. By similarity criteria of triangles, angle ABE is equal to angle CDE, which is equal to 90. Triangle ABD and CED are similar by SAS criteria. The sides including these angles ABE and CDE are proportional. Therefore, CD by AB is equal to DE by BE is equal to CE by AE. CD is equal to 90 centimeters, that is 0.9 meter. AB is 18.9 meters, height of lighthouse. BD plus DE is equal to BE, which is equal to 40 plus X. Therefore, CD by AB, 0.9 by 18.9 is equal to 1 by 21 is the ratio, which must be equal to CE by AE is equal to DE by BE. DE is X, BE is 40 plus X. Therefore, 1 by 21 is equal to X by 40 plus X. Cross multiplying, we get 20X is equal to 40. So, X is equal to 2 meters. Therefore, the boy shadow stretched is 2 meters. Then 1 by 21 is equal to CE by AE. Therefore, AE is equal to AC plus CE. That is 21 CE is equal to AC plus CE. Therefore, AC is equal to 20 CE. Ratio of AC is to CE, therefore, is 20 is to 1. Applicability of Pythagoras theorem to obtuse angled triangles. ABC is an obtuse angled triangle. Extend line segment BC base to D. Draw AD perpendicular to DC. Now ADC is a right angle triangle. In ADC, AC squared is equal to AD squared plus DC squared. Extending, AC squared is equal to AD squared plus DB plus BC squared. DB plus BC is equal to DC, therefore DB plus BC whole squared. Therefore, AC squared is equal to AD squared plus dB squared plus BC squared plus 2dB into BC by applying the identity A plus B whole square. Therefore, AC squared is equal to AD squared plus DB squared plus BC squared plus 2dB into BC. From triangle ADB, AD squared plus DB squared is equal to AB squared, that is equation 2. Therefore, AC squared, combining equations 1 and 2, AC squared is equal to AB squared plus BC squared plus 2dB into BC. In the problem given below, DEF is an obtuse angled triangle. Find DF given DE is equal to 3 cm, EF is equal to 4 cm, ME is equal to 2 cm. By theorem above, DF squared is equal to DE squared plus EF squared plus 2EF into EM. Therefore, 3 squared plus 4 squared plus 2 into 4 into 2 is equal to 9 plus 16 is equal to DF length, hypotenuse of the obtuse angle triangle is square root of 41.